In this example, for the polynomial inequality we want to solve, notice we're not comparing to 0 this time, and so I think what might be helpful to do first is let's make sure we have a 0 on one side. So what I'm going to do is subtract that 24x so that I am, in this case, greater than or equal to 0. We typically want to compare to 0. There's other ways to do these problems, but I like comparing to 0. As we talked about in the last video then, the first thing we'll want to do is find the zeros. And we could find them using the table, which I'll show you in a few moments. However, since I like to factor, let's rely, at least for right now, on factoring this just to find what my zeros are. So I notice there's a greatest common factor this time of x. So I'm going to divide out an x, or factor out an x. And then what's left, this trinomial in parentheses, I can factor rather simply. I just need to find two numbers that multiply to negative 24, but at the same time add up to negative 5. And so the two numbers that are going to do that are going to be a negative 8, so x minus 8, and then a positive 3, and x plus 3. And so now that the polynomial is factored all the way, finding its zeros is fairly easy to do. I'm going to go ahead and plot these zeros on the number line because these represent the spaces, or the numbers, where the graph may change direction from going from positive to negative. So one of my solutions, one of my zeros, is going to be at 0. Another 0 is going to be at negative 3. And then my final 0 is going to be at positive 8. So those are the three intervals I want to divide my number line up into. At this point, I'm going to switch over to my calculator and take a look at the graph and the table to determine whether the intervals are positive or whether they're negative, because knowing that will help me answer this inequality, because this time I'm looking for where the graph is greater than or equal to 0. In other words, where the graph is positive or above the x-axis. Where it's above the x-axis. So let's go ahead and switch to the calculator and take a look. Alright, so you'll notice the polynomial I typed in my calculator was the unfactored polynomial. I just want to show you how, if we didn't want to rely on factoring, or if we couldn't, how we could still find those zeros using our table. So you could type this in, you could type the original in, it doesn't matter. So let me go ahead and go to my table just to show you how we could find our zeros. If I take a look, notice in the y column, wherever y is equal to 0, there's where my zeros are located. So 0 is a 0. 8 is also a 0, and if I scroll up to negative 3, I betcha, yep, y is 0, so negative 3 is a 0 as well. So what I want to do then, since I'm in the table, is let's just use it to find out the sign of the graph in each interval. So pick a number smaller than negative 3, so maybe negative 4 or negative 5, and check the sign of the y value. The y value is negative, so I'll put a negative sign on my graph, or on my number line, meaning if I check the graph, which I will in a second, the graph will be below the x-axis in that interval. Pick a number between negative 3 and 0, like negative 2 or negative 1, and I can see that my y value is positive. My graph will be above the x-axis in that interval. Pick a number between 0 and 8. So anything down here, notice my y values are all negative. And then finally pick an x value bigger than 8, so 9 or 10. And I can see that there, my y value is also positive. Notice my signs flip-flop. We talked about in the last video, that's usually the case, but not always. Sometimes your signs won't change. If I want to confirm this by looking at the graph, which we don't need to do, but I think it's a good idea to use the table and the graph together, it looks like it's a little bit off the screen, but I can see that over here, my graph is below the x-axis, just like we predicted. Between negative 3 and 0, the graph is above the x-axis. Between 0 and 8, once again, the graph has dropped down below the x-axis, it's negative, and then anything bigger than 8, the graph was way up high, it was also positive over there. Okay, so my table, my graph all confirm those signs. To answer this question, then, we want to know where the polynomial is greater than or equal to 0, in other words, where it's positive. Well, between negative 3 and 0, there's an interval where my graph is positive, and then from 8 onwards to infinity was another interval. This time, because we could be equal to 0, I included the square brackets, because at negative 3, your graph is 0, it's right at the x-axis, so I can be equal to it, so I can use brackets.